Okay, here's the problem. In the Flash is able to do something that's kind of a common trope for him. He's so fast that when a bullet is shot at him, at someone he loves or whatever, he sees it flying through the air. He goes so fast that time stops. Really kind of neat there. Time stops. Now, first, let me explain that I understand that the Flash molecular level would be just as susceptible to the things as that for which he stops. Okay, please understand. I get that, but let's state at this point he could stop time. Now, he will usually take the bullet and either turn it or just remove it, and everything's wonderful. Let's just play with the one where he changes it for a second. He turns it, and the bullet zeroes off. Now, I don't know if it would do that. And then my problem here, and what I'm really trying to work through at this point, this is one aspect of this issue, is what if when he turns it, it just starts doing this. Now, granted, the wind would make it tumble, but it continued in that trajectory with the force. Or it turns and does do this. If it goes this way and then starts continuing on that same path, then all I've got to say is that force is a separate subject and it's not entangled. However, if it does turn and spins off that other way, then the force is entangled with the object. Stopping it in time, it should still have the same conditions that it has in other times. At first I wondered how difficult it would be to, as the bullet was sitting there, even though you've stopped at time, to grab that bullet, because you would still have the force and magnitude hitting it, right? So as I'm trying to pluck it out of the air, it may be rather difficult to do. Now, that's one thing. Then the next question, could he even see it? Now remember, the Flash has some type of weird electrons, and his matter is not following the same rules, but that's part of the experiment. So Flash now sees this, or does he? Here's the problem. Items themselves are actually made of atoms, which are particles, negative and positive particles. And those negative and positive particles have valence shells. And that's what makes them combine. That's the chemistry. They share the atoms and electrons. And so, for example, let's just look at a basic one we pretty much all know. Water is 2 hydrogens and 1 oxygen. As the hydrogen has shared, it's given its electron, that electron goes curlicues, basically, as it goes around the outside, as it completes all the valence shells with the other hydrogen atom. Pretty cool. But now those electrons aren't moving. As a matter of fact, what happens at time stopped? At this juncture, you have a proton, for example, without another atom, positive particle. Because from moments in time, water, since the hydrogen's giving up its electron, there are moments where it probably needs an electron because it has nothing in it. A nucleus without a shell. Meanwhile, the oxygen goes from states of completed to otherwise. So that means, as much as anything, it is the vibration. My thing is, it's the vibration that you actually see in objects. It requires time to actually see things. We know this anyway because our eyes shake. It's one of the things that we do. But in our experiment, what do you see if everything is truly stopped? I don't know. Can you see the particles? Do they still exist at some fundamental level, even though they're no longer having nuclear energy at that one given second. I'm not sure. This is my problem. It's the Flash issue. It's not that it's a bad thing. It's not that really I don't know whether it's even feasible. But when you stop time, things don't seem to things don't seem to work the same way. They require time, which is a concept. Time's a passing concept. I mean, if in space without anything, Einstein argued that there may not be time there because there's no ability to measure it. But time is required at a molecular level. It appears by what I'm thinking here. This is what I'm working on.